Hello, I'm Mrs. McTaggart, and in this video we're going to recap the significant figures topic. So you've probably already seen this being taught. This is just like a little revision exercise to try and refresh your memories on it. So here are two different types of numbers. The first one up the top, I call that a big number. Okay, so I call that big numbers. And the one down below, I call that the wee numbers, right? They are always numbers at less than 1 or small, right? So when you have big numbers, the thing to remember is that these zeros at the end are not significant. So the bit I'm underlining there, these zeros are not counted as significant figures. So this number 356,000 or 356,000 at the moment only has 3 sig fig. And that would be the 3, the 5 and the 6, okay? The zeros at the end don't count, but we have to keep them in there when we are rounding to keep the place value the same, so that 3 is still in the 100,000 column, and the 5 is still in the 10,000 column, and the 6 is still in the thousands column. Because if we had a big number and we just rounded to 356, we've completely altered the size of it. So zeros at the end are not classed as significant. However, the confusion comes when we look at these wee numbers, okay? So, the zeros at the front aren't significant. We don't count them, okay? They are there, again, to keep the place value. If we suddenly said that this number rounded to maybe 736, we've turned it from a really tiny number, less than 1, to being bigger than 1, which can't do. So, zeros at the front don't count. They're for place value purposes only. However, this is a confusion bit. There's 2 zeros at the end of this decimal, okay, after the 2. Now, they are significant. They are important because they don't need to be there. Your calculator, if you type this into your calculator and press equals, would cut them off. Because mathematically, we don't need zeros at the end of a decimal like that. But if they are there, they must be there for a reason. Therefore, they are significant. Maybe we were asked to round this to 7 decimal places. And to do that, there had to be 2 zeros there to keep 7 places. Very unlikely, but that's a way to think of it. So at the moment, the only significant figures in this number, the significant figures, in this number are the 7, the 3, the 6, the 2, and then we have to count these zeros because remember they don't need to be there. So this number here at the moment has 6 significant figures. All right. So what we're going to do is we're going to look at some questions. We're going to decide how many significant figures each of the numbers have, and then we're going to do a wee bit of revision of the rounding. So it shouldn't be too long. So how many significant figures do each of these numbers have? So I am going to get out my pen and I'm going to start doing dots above them because that's how I do significant figures. So we count along and we go, right, from the left-hand side, there's a 3, a 2, a 3 and a 2. All 4 of them are significant figures. So that has got 4 sig fig. On this number, 24,000, we count the 2, we count the 4. Remember what I said, zeros at the end don't count. So that only has 2 significant figures. On the number 8.0, you could just as easily say to me, well, that's the number 8. So why is it 8.0? It must be 8.0 for a reason, i.e. the question said give your answer to 1 decimal place. So because there's a 0 there that doesn't need to be there, we count it. So that one has 2 sig fig. 0.83, remember the 0 at the front doesn't count, that's our place value, so that 8 is in the 10ths column. So we count the 8, we count the 3, that also has 2 significant figures. On question 5, we don't count any of those zeros at all, they are for place value, but we do count that 6, so that has got 1 sig fig. And then my last one, 5.20, remember that 0 doesn't have to be there. But maybe this was a money question, or you were asked to do it to 2 decimal places, and to do that we had to put on a 0. Maybe it was 5.1987, and when that rounds up, the 19 effectively goes to 20, so it becomes 5.20. So because that 0 is there, when it doesn't need to be, we count it. So this has got 1, 2, 3 sig fig. Okay, so now we're going to take 6 numbers and we're going to round them all to 1 significant figure. So starting from the left, I'm going to put in my dot. That means I'm keeping the 8. The next number is a 2. A 2 does nothing in rounding, so that becomes 8. And these 3 digits here have to become zeros, so that is still an 8 in the thousands column. On the next number to 1 significant figure, I'm going to keep the 9, but that 6 is going to make the 9 go up. And 9 technically goes up to a 10. So that is going to put a 1 in front of where the 9 is. So this is going to become, instead of 96,000 and something, it's actually going to go up to 100,000. So 100,000, like that. So there are the 4 zeros that I had to have. And then because the 9 effectively rounded up to a 10, there's the 10 at the front. So that one, it would be 100,000. Okay, to one sig fig, this next number, I'll put my dot above the 3. I'm going to keep the 3 only. But the 9 after it makes the 3 round up. So that just goes to the number 4. Do not put on any zeros, right? At the moment, this is it to one significant figure. If I do that, it's now got 2. If I do that, it's now got 3. And if I do that, it's now got 4. Remember, zeros don't have to be at the end of decimals like that. So we don't have to turn all the extra digits into zeros at the end of a decimal. It's only at the end of big whole numbers that we do that. So the answer here is just 4. Okay. On the next one, remember the 7 is the first significant figure. So this is going to be 0.7. No, it's not, because the next number is a 5. So it's going to be 0.8. On this one, the first one that's going to count is the 3. The next number is an 8. So that means that's going to round up to 0.4. And then my last one, always to cause confusion, it's a 9. The 9's going to round up because of the 9 after it. So that really moves into this column. So where I've put the arrow is now going to become a 1. So that is 0.001. And it's just by coincidence that all of them bar question 1 rounded up. It's just my choice of numbers. It won't always be rounding up the way. Right, similar numbers, but now we're going to do 2 significant figures. So 2 dots this time. 1, 2. 6, 5. The next number's a 2. So it's 6, 5. The 2 becomes a 0 to keep it a 3-digit number. Question 2. 2 dots above the 8 and the 3. But that next 8 is going to turn a 3 to a 4. So that's 8, 4. And then 3 numbers at the end. So 3 zeros. So remember, you're only adding the zeros if it's a big whole number. On question 3, to 2 significant figures would be 6.7. But the next number is an 8. So that goes to 6.8. On question 4, the 0 at the front don't count. So we're keeping the 8 and the 4. The next 4 is not going to change it, so it's just 0.84. Okay, the one with the 7986. So we're going to keep the 79, but the 8 is going to make that go up. So it might be easier to think of it as 79. 79 would go up to 80. So that would be 0.0080. Now you might just be tempted to leave that as that, but that's only got one significant figure. So we have to put the 0 back in. Okay, and it's 0.0080. And because they wanted 2 sig fig, that's why that extra 0's on the end. And then here again, we've got 99, but that's going to round up to 100. So I'm going to show you what happens there. So 0. So this is going to fall into this column. So 0.001. That's only got 1 sig fig. Again, I have to add a 0 to make it have 2. If you were accidentally going to say 100, that's actually got 3 sig fig. So we're going to take that back off. So there's your answer to that one, to 2 significant figures. Obviously, you can then be asked to round to 3 significant figures, etc. But I've not asked you to do that for any of these. But it's just an extra wee step onto it. And if you can do 1, you can do 2. Hope that has helped refresh your memories. Oh, wait a minute. No, I've remembered. I've got another. The last part of the topic, we always rounded to 1 sig fig to allow us to estimate. So we're going to round each number first. So the first one, we're going to keep the 6. The 2 won't do anything, so that becomes 6,000. Times, keep the 5, so that's going to be 5,000. And then you do 6 times 5 is 30. We ignored 3 zeros and 3 zeros, so you put on 6 zeros. 1, 2, 3, 1, 2, 3. So that actually gives you the number of 30 million. Similarly on this one, we're going to keep the 7, so that will be 7,000. Divided by, keep the 1, but it's actually going to turn into a 2. So you're left with 7,000 divided by 200. We are going to cancel off some zeros in each number. And you're left with 70 divided by 2, which we all know is 35. So you'll also maybe have some of them asked to do as well. So thanks very much for watching. I hope this has helped. Bye-bye.